How's it going, everybody? And welcome back to our video series on Nexus dashboard. In this video, I am going to take some time and I'm going to walk you through. We got Nexus 1 through 4 all booted up, ready to go. I'm going to go ahead and walk you guys through the template that is going to be used to configure the fabric. We're actually going to be using several different templates. As we progress through here, there'll be a template for the fabric itself here. There will be one for external connectivity between Nexus 7 and 8 and the Cat AK 15 and 16 and things like that. So I'm going to be focusing most of my time, at least in the beginning part here in this portion, and then we'll take a look at some further on configuration on one of those things being adding more switches to an existing fabric, which in NDFC you can do. In DCNM you can't in a greenfield. You'd have to already have the switches ready to go, and then they can just be learned. So with that being said, let's go ahead over to the NDFC. I'm going to go ahead and get out of the way. So if you click on Fabric Controller, this is one of the new views here. So Fabric Controller here. And then I'm going to go over here to the topology. And then when you add a topology here, it's going to show up in this little area right here. For the LAN, I'm going to click on Fabrics. And I'm going to click on Actions and then create a fabric. Now this fabric's name is going to be DC1. You can name it whatever you'd like. I'm going to click on Choose Fabric. Now let me take a minute here and just kind of go through what we have here. Now every one of them I'm not explicitly I won't be able to give you in-depth details on every one of them because I've only worked with a few of them. But you have the data center VXLAN EVPN, which we already actually kind of covered already. Fabric for VXLAN EVPN deployment with Nexus 9Ks and 3K switches. Campus VXLAN fabric if you want to deploy Cat 9K switches. So this would essentially allow you to do what SD Access does inside of DNA Center. Where we don't have Cat 9K switches, but if you did, you'd be able to leverage Nexus Dashboard to do that. BGP fabric, BGP or fabric for an eBGP based deployment with Nexus 9Ks and 3Ks. Optionally, VXLAN EVPN can be enabled on top of the eBGP underlay. What that means is normally in a fabric you're going to either choose IS to IS or OSPF as your underlay IGP to take all of the point-to-point underlay connections. So all of these connections right here. All these connections right here are going to get an IP address attached to them. And then there's going to be a couple of loopbacks that are going to be created on all the switches, and that is going to be how they form BGP peerings, and you're going to normally deploy with an iBGP deployment. If you choose to go this route, you're basically saying you want to do an eBGP underlay. You don't want to rely on an IGP, and you're going to form a BGP peering over that. So then you have flexible network. We have a fabric for flexible deployments with a mix of Nexus and non-Nexus. So you can kind of mix and match. Fabric group, a domain that can contain enhanced classical LAN and external network fabrics. So there's quite a few options, right? We have classic LAN. So we can do, like, if you had traditional, and when they say traditional or classic, they're meaning your normal networking, layer 2 trunk, VLAN, spanning tree, all that good stuff. So we will be taking a look a little bit about that when we get into, I have a port channel that we're going to be configuring down here with switch 13. We have a VPC pairing that we're going to be configuring on this pair here, and so on and so forth. So you also have LAN monitor where you can look at discovery and inventory management. This is another option that's out there as well. It depends too. So what's cool about Nexus Dashboard is it's not just configuration. So you can do monitoring and things like that if you'd like to do so, but you also could do things like image management. So for example, instead of you having to go through and upload a new, like a USB drive, you can actually manage the software images that are going to be pushed to the switches themselves. So it can be a SWIM, software inventory management. So you can go ahead and deploy images from NDFC as well. Not a lot of customers use that, but it is an option. Then you have VXLAN EVPN multi-site, domain that can contain multiple VXLAN fabrics with layer 2, layer 3 overlay extensions and other fabric types, which means you can stretch layer 2 if you'd like to do so. Multi-site interconnect network, which is going to be a fabric to interconnect VXLAN fabrics with a mix of Nexus and non-Nexus devices. And then your external connectivity network and so on. We'll be taking a look at this one down the road. I am going to choose this guy. So if you would like to dive more into this, feel free to do so. I'm going to click on select. Now let me go ahead and walk you guys through this. This is where we're going to be spending quite a bit of our time, at least in this video, well, going through it. So the first thing you need to do is you need to have a BGP autonomous system number. And as you can see over here, you can use a 4-byte, or I'm sorry, a 2-byte, where it's, you know, the 32-bit address, or you can use this guy. So it's up to you and how you want to go about doing it. So I'm going to say 65001. And then if you want to do an IPv6 underlay, you can. The fabric interface number, the point-to-point underlay, is going to be point-to-point. You could do it unnumbered if you'd like, but most of the time we just do a connection there. You can get more specific with your subnetting too. You can go to /31 if you'd like. I'm going to keep it as a /30. What routing protocol do you want to use in the underlay? I'm going to use OSPF, but you could do IS to IS. How many route reflectors are you going to have? Well, you could do 2. You could do up to 4. So which means is Nexus 1 and Nexus 2 are going to be our route reflectors for our BGP deployment. What is the Anycast gateway MAC address? So this is kind of the interesting one. So those of you that are familiar with HSRP or VRRP kind of eliminate that. It's sort of like that. So first hop redundancy capability in a VXLAN fabric. The idea behind Anycast gateway means that you a lot of times you're not going to have a server running a singular application in most cases nowadays. You're going to have some sort of virtualization environment sitting southbound to your leafs. Your leaf switches are going to be Nexus 3, Nexus 4, 5, and 6. So that means that you're going to probably have like ESXi. You're going to have that sitting southbound of you. Then that environment itself is going to be running something on top of it, like you're going to have the vSphere distributed switch. You're going to have port groups, trunk uplinks to the top of rack switches, which is what the leafs are. Top of rack and leaf switch are the exact same thing. So what will end up happening is you might have a VM sitting on server 31 that gets moved over here to server 39. What will end up happening is, regardless of the VLAN that the VM sits inside of, that's IP addressing range, whatever it might be, every SBI that you create that's going to be VXLAN aware is going to have the capability fabric forwarding Anycast gateway mode enabled on it. Meaning that every SBI is going to have the same MAC address. This guy, right here. Now I'm going to change this over to be 0001.0001.0001. That is the MAC address I'm going to use. So if I saw the other one in a running config, I would know immediately that somebody deployed that switch at some point with either DCNM or Nexus dashboard. Just because of the fact that I know it from that deployment. So that's where that basically comes into play. Replication. So how do I want to do replication of BUM information? Broadcast, unknown unicast, and multicast. This real simple one is going to be things like ARP. If I have a device attached to my leaf switch and it's trying to communicate with another device attached to another leaf switch, how do I allow that communication to happen? Normally in a trunked environment, you would ARP across the network and you would have 802.1q tags that would allow the communication between switches to happen. You don't have that anymore because now everything's routed. You need some way to encapsulate that. If you are going to do any type of advanced configuration, you can, and I recommend going to ingress replication. Ingress replication essentially just means unicast. So instead of you having to send to multicast, which means you're going to be sending to this entire group range, you're going to be, it's actually kind of interesting. When you do ingress replication, when you do BGP EBPN with it, there will be an additional route type, which would be the IR route advertisement, MAC type 3, which is going to be a pointer to the leaf switch that actually owns that particular IP address. Every device gets one. I am a fan of IR. It cuts down on the multicast unless the customer has a requirement for it to do multicast in the overlay, or what they refer to as tenant routed multicast, then there's really no need to run it. If you don't have that, run IR. Most of my customers don't do multicast in the overlay. I have a couple that do, and since they do, in order to run multicast in the overlay, I need to have a multicast in the underlay operational. Because the idea is you need to make sure that there are multicast tunnels between your leaf spine and leaf, and your leaf and your spines. That multicast traffic has to be available there first before you can build an overlay on top of it. So for those of you that are familiar with like multicast VPNs inside of MPLS VPN, in order to run multicast over MPLS, you need to have your MPLS backbone multicast aware already. So you can't run TRM over an IR replication. It doesn't work. So I'm just going to choose IR. The cool thing about that though is once you have chosen a particular replication mode, it doesn't mean you're locked in. What you can do at any point in time is after the fabric has been deployed, even if you have a functioning production fabric working, you can always circle back. Let's say the customer, they come to you and say, hey, we need to enable multicast in the overlay, or we have multicast requirements, or whatever they tell you need to do. You can come back at any point in time and go to the fabric devices, fabric configuration. You can edit the fabric and then change the replication mode. What it will do is it will recalculate and deploy, and you just have to push some more config. It's very, very easy to do. So for that, I'm just going to do IR for that. And as you can say, if we were doing multicast, there's a bunch of operational configurations you could do underneath the hood. I'm going to do this. I'm going to uncheck that button because I don't need it to be there, and just choose IR. There we go. So that's basically how that comes into play. VPC, virtual port channel. So let me go ahead and get out of the way. We're talking about that for a minute now. The VPC Pure Link VLAN. So this is going to be a communication channel between the devices. And so instead of a VXLAN fabric, especially when you've got VPC involved, and we will have VPC involved, there's a unique thing that comes into play with VXLAN called equal cost multipath, or ECMP. And I've been dealing with this now for quite a while, so I'm pretty familiar with it. The concept is actually very, very simple. There is the requirement inside of VXLAN fabric when you have two different switches acting in a VPC, but you're only going to singly attach a connection to one of the members in that VPC, one of the VPC switches. In order for that device to be able to replicate the information to the rest of the fabric, it can do it on its own, right? So if switch 1, let me go ahead and show the topology. If switch 5 here has a singly attached device here, and it will take that information, it will propagate it to the rest of the fabric. It'll tell Nexus 1 and 2, which are the spine route reflectors, that, hey, I've got this device attached, let everybody else know. Well, Nexus 3 and Nexus 4 will learn that. Here's the caveat. Nexus 6 will not. There is no replication from the spines down to the other member of the VPC. It's a loop prevention mechanism. So, because you're not going to learn that information back in from the fabric, what will end up happening is you need some sort of mechanism to allow Nexus 6 to know what's going on at Nexus 5. There's two ways that you can do that. Through IGP, so you form a peering between the two and you allow the propagation to happen. That's assuming that you're not going to be using BGP to connect outbound out of the fabric. If you're going to be connecting outbound of the fabric to something else, you'll need to do some sort of redistribution between whatever IGP you're using and BGP. Not a good idea. I don't recommend this at all. As a matter of fact, any customer that has either suggested this or had it in operational, I have strongly advised them against going that direction, and I've come up with workarounds in order to make that happen. So I do not recommend you do that. What I do recommend you do, and it's basically a requirement, there's this thing known as the MCT, the multi-chassis trunk, which is what this is actually talking about right here. This is what's going to allow the VPC members to form an IBGP peering between each other. Nexus Dashboard doesn't do this because we don't have the requirement in this design. But in the event that you have devices attached to your VPC pair, let's say this the border gateways, the borders up here, or VPC enabled, you would need to do this here as well. What would end up happening is if you did this, you would need to form an IBGP peering between the VPC members in order for them to replicate information to each other inside of the VRF. The reason why they need to have that is because whenever you have traffic coming to a member, you're going to have two uplinks, right? You have one to each spine. So BGP is going to put multipathing in there, or in a max paths and stuff like that. That configuration, it's actually right. It's under one of these protocols. Where is it? Sorry, it's not underneath here. It's going to be. Is it under here? We'll talk about this more in detail when we get further along, but there is going to be. Actually, it's not here. I'll show you when the fabric gets pushed, or sorry, the configuration gets pushed to the fabric. I'll talk about that more in detail later. But you need this VLAN to be there to form that IBGP peering. Now, what's funny is it doesn't do this out of the gate. Like if you need this deployed, it doesn't do this. So there's some, and down here, actually it's on the protocols. Yes, right here. So you have this template config. This is going to be essentially a peering configuration. This is what they refer to as the free form configuration, which basically allows you to add any additional configuration to the switch that you need to do that doesn't come by default in the template. So if you need to form an IBGP peering between your VPC members in order to do route replication for a connection that you have landing on one of your members but not the other, that other member needs to know about that route. Because if it doesn't, you're going to run into intermittent issues. I troubleshot it a bunch of times in a bunch of different environments. I'm well aware of the situation. It's just that's why I'm kind of spending a little bit more time on it than I probably should, but it's important for you to understand it. Now, one thing that I do not like to, and this VLAN right here is fine. Whatever VLAN you want to choose from, all of this is configurable. I happen to just choose 3600. The VPC peer keep alive option. Normally, customers like to do this over the management network. A lot of times, if customers are going to do in-band management of their switches, then a lot of times we'll just connect, a little 1-foot Ethernet cable that's going to connect the management ports together. We'll make that our VPC peer keep alive. Everybody's happy. If the customer decides that they want to use the out-of-band management interface as management, and that's completely fine as well, then I will come in here and say loopback. Now, you can do a loopback to loopback peering as long as you have an IGP working. You need to have this, but it needs to be routed from the leaf northbound, right? If you're doing trunks northbound for some reason, then this isn't going to work. Or you need to take a dedicated interface, and I'll show you another topology real quick, what I'm referring to here. Close this out real quick, and let me come over here to Nexus. Let me give you an example of what I mean. Right here. So let me go ahead and get out of the way. You see right here, Nexus 3, Nexus 4. You see Ethernet 1/1. Well, this happens to be in its own dedicated VRF, and it's used for the VPC peer keep alive. So I don't have the management port utilized here. Normally you would do that. So if you don't use the management port for whatever reason, you need to dedicate a specific interface for the VPC peer keep alive. So So just keep that in mind when you're doing your configuration and all that good stuff. So that's where that comes into play. Let me go ahead and open this back up. So that's where that comes into play. I'm going to choose loopback. You have the auto recovery timer is 300 seconds. That's 6 minutes. Restore timer is a minute, 2 minutes 20, or 2.5 minutes. The VPC peer link port channel ID 500. You can use whatever you'd like. The VPC advertised PIP. This is the primary VTEP IP address as the next hop of prefix routes. This is one of those situations where if you need to pin traffic to a particular member of the VPC, you can. It would actually advertise from this. This is kind of more of an enhancement if you're dealing with border gateways and things like that. Most customers aren't going to go this route unless they need to. Enable the same VPC domain ID for all VPC pairs. They say not recommended, and what they mean by that is in the event you have a situation where you need to do a back-to-back VPC, you must have 2 different VPC domains in order for that to work. So a lot of times what you won't do is you will give, I mean, you could give them all the same VPC domain ID, but then you wouldn't be able to take one VPC pair and another VPC pair and then form a port channel with each other, like I did, and the other topology had one where Nexus 1 and 2 and Nexus 3 and 4 had a back-to-back VPC setup between the two. That would you would need dedicated. Sorry about that. There was a loud boom in my neighborhood, and I was like, "What was that?" Apparently, it was lightning. Anyway, so there's that. So what I'm going to go ahead and check this because I don't plan on having the same or doing a back-to-back VPC pairing. The domain ID. So you can choose whatever you'd like. One is fine. Enable QoS fabric peering. Not really worried about that right now. There's that. So next is going to be protocols. Go ahead and get out of the way. So the underlay routing loopback ID 0. The VTAP is going to be 1. Then the underlay routing protocol tag underlay, that's going to be OSPF under the routing. So it would be router OSPF underlay, and then the area ID is going to be 0. You can choose to do authentication if you'd like, and then the key and then the key string. So what you would do, like key ID 1, and then you type in here like Cisco 123. Right, that's basically what you would end up doing. I'm not going to do that. You have that. We don't need the Anycast loopback ID for this because it's VXLAN 6. IS to IS is all going to be shut down because there is nothing IS to IS to configure. BGP we could do here if we wanted to. We're not going to do BGP authentication either. BFD, so Nexus 9K Vs don't do BFD, but if they did, I always turn it on for customers. So I do BFD, I do BFD for OSPF and ISIS. I don't do it for PIM, but I do it for BGP and for OSPF, only because of the fact that it gives me fast failure detection. It allows me to flip over a link. Most of the time we're dealing with 2 spines and several leaf switches and stuff like that. So that's basically where that comes into play. If there's any additional configuration, you would put it here. For the advanced, we have the templates. There's a bunch of different templates we could throw in here. As you can see, there's some stuff going on here. I never mess with this. I just let it. I keep it the way that it always is. If I wanted to do private VLANs, I could, but then you'd have to define your secondary network and all that good stuff. I don't really worry about that. Your site ID is 65001. This is going to be if you're dealing with EVPN multi-site. This is where that's going to come into play, where each EVPN fabric, a lot of times you're going to tie it right to the AS number. So you need uniqueness for routing updates. So that's essentially what that's going to mean there. But so that's basically what all that does right there. The last couple ones here, we have the intra-fabric interface MTU, which means going to be connections between Nexus 1 and Nexus 3. And then we have the layer 2 host interface MTU. This is going to be for traffic southbound of your leaf switches. So what I do is, unless they tell me otherwise, I bump this down to 1500 because the fact that unless there's a reason for it, I don't mess with it. Like if there's going to be, for my lab, I don't need 9216. I'll do 1500, but in a production environment, I always keep it 9216, unless there's a reason not to. So there's that piece. And then VTEP hold down, your control plane policing and things like that. I do mess with some of this stuff right here. VXLAN operations, administration, and management for troubleshooting the fabric if you need to do so. In the event that you have a scenario where you've got VDI, virtual desktops and things like that deployed in your fabric, and you're going to be having virtual machines and stuff like that connected, DHCP enabled in the fabric is going to be something you're going to want to turn on. I'm not going to really have that, but it actually doesn't work. I've tried getting that to become operational. VXLAN DHCP doesn't work for whatever reason. I'm not exactly sure why. I've tried testing it out. It doesn't work in a 9K world, at least last time I practiced it. Then we have the PBR. If you want to do policy-based routing to do things like service insertion, you would turn that on down the road. Anycast border gateway advertised PIP. We're not going to be messing with this, but essentially, if you've got two border gateways on either side of a connection, let me do it like this. If you've got two border gateways set up, and you have a DCI connecting them between us, so just imagine that my fingers are connected to each other by a fiber cable. What will end up happening is I'll get routes in from both fabrics, and they'll be passed back and forth across the border gateways. Essentially what will end up happening is I will need, instead of advertising the VIP, the IP address that's shared between the two and load balanced over both DCI circuits, I'll advertise the primary IP address on the loopback that I peer from, and that will that'll basically allow me to pin traffic one way or the other. It's supposed to be making sure traffic goes one way or the other over the DCI link. Nobody really uses this unless you have a use case that's specific for it. I've used it once for propagation, but at the end of the day, it really doesn't make much of a difference. And then we have some of the other options stuff here. We have greenfield cleanup option. This is disabled. If you want to do precision time protocol, an enhancement to NTP, you can do that as well. MPLS handoff. Are you literally trying to bring MPLS LDP into the fabric? And you could do a peering off that if you'd like. And then we have some other stuff depending on the platform. And if you're doing MACsec layer 2 encryption, you could use that as well. Spanning tree stuff if you wanted to do that, but we're not doing it. So we could say spanning tree root bridge protocol. We could say we would just type in PBST, and then we would give our priority is say 4096. So we'd want to make sure that the 9K switch, like the N3 or N4 or N5, N6, it would be the root bridge for our deployment. We're not going to be doing that, so we don't really care. So there's some configuration in here. If you'd like to do it, you could, but then this configuration must match whatever would be in the running config. So you would need to know that ahead of time. And then let me go back up to the top real quick here. Resources, this is going to be what addressing space are you going to use. So for the underlay, underlay subnet, I'm going to use, what IP addressing range am I dealing with here? 1, 2, normally I would do 1.3, 2.3, 1.4, or 2.4. So the addressing space here is fine. The underlay routing loopback range is fine. Same thing with this guy. It gives us a couple different spaces to use. I'm going to actually change this up to be 10.1.1/24. And this will be actually 10.1.0. I'm changing this up so that it makes more sense. And this will be 10.1.1. The underlay subnet is going to be 10.1.2. Actually 10. Yeah, 10.1. 10.1. We do 10.0.1. And then that's that. Because I want this one here to be where I want it. Because let me get this is /24 as well. The idea here is I want it ones in these IP addresses so that I know it's DC1. And then now we have the layer 2 VXLAN VNI range, which means that this is going to be the VXLAN network identifier range that I use inside of the fabric. So if there's any layer 2 communication, this is where that's going to come into play. So I'm going to choose, and they have to be, it doesn't really matter what range you use here. I'll use 3000 to 3100. I'm sorry, 3100. Actually, you know what? I'll take that back. I'll do 2000 through 2100. Because it's layer 2, 2000 makes sense to me. Layer 3, I'm going to do the same thing. It's going to be 3000 through 3100. Now, the network VLAN range, this will be for the overlay networks. So, essentially, this is going to be the VRF range. I'm going to use, in this one here, I'm going to use, this will be the overlay. So, I'll choose the overlay network VLAN range. So I'll use, so these two right here are not VLANs at all. So I can use whatever range I want. So I'll use 10 through 20. So it really doesn't matter here because I'm only going to be creating a couple of VLANs anyway. The VRF VLAN range. This is going to be for communication outbound towards an external connection right here. So Nexus 7 and Cat8K15. So what I'll do is I'll come down here, the VLAN range here, and I'll use 30. Actually, what's the 7 and 8? So I'll use 70 through 80. Because I'm like, actually, you know what? I have 7 and 8. I'm going to be creating 3, 1, 2, 3, 4. I'll use 70 through 70. Well, 70 through 80 is fine. Now, the .1Q subinterface here, I'm going to choose to be the same. I'm going to say 70 through 80. Just like that. So if I create one, it's going to show up as the VLAN range is going to be 70, and then the .1Q range will be 70. So I'll be using encapsulation .1Q 70. There we go. The VRF Lite deployment. So VRF Lite inter-fabric connection deployment if back-to-back and external is selected. Well, essentially what this means is when I do this communication right here, VRF Lite, or I do a VRF Lite peering out to Cat8K15. And we'll talk more about that when we get to that point. So I'll be configuring that manually. The VRF Lite subnet range, what subnet do I use? So for point-to-point interfabric communication, it's going to grab an address space out of the gate for me. If I want to do so, I am going to leave this one alone. It doesn't really make much of a difference. Service network ranges for VLANs 3000 through 3100. That's fine. It doesn't overlap with anything I got going on. I'm going to come up here to manageability. There are NTP servers, DNS server IPs, syslog, all that type of stuff. And band management. I'm not going to mess with any of that. Bootstrapping. If I wanted to do, I think, is it power? Yeah, bootstrapping would be if I wanted to do things like power on auto provisioning or anything like that. This is where I basically would start that process. Enable automatic IP addressing for POPE. I'm not going to be doing that. Configuration backup. I can configure backups at whatever time frame I want. And then flow monitor, do I want to do NetFlow? So that's basically it. I'm going to go ahead and click on save. That's all the details that I needed. This is it. So Fabric DC1 was added with the below message. Performance monitoring feature is not started. Please start performance monitoring from feature management and retry this operation. Did I turn that on somewhere? I don't remember turning performance monitoring on. Protocols. So I'm going to minimize this real quick. I'm going to go to the admin console and get started. I'm going to say services. You can do action, is it right here? I don't know why it gave me that. That's kind of weird. So, actions, edit fabric. Oh, that's why. Sorry, I was like, it's got to be there somewhere. So I'm going to go ahead and click on save. It's going to go ahead and create the fabric for me. Okay, please perform recalculate and deploy if there are any switches in the fabric prior to deploy. Okay, so I can click on switches here, and then that's going to bring me over to here. Now, one thing that I will caution you on is this. I'm not going to go through and actually deploy the switches in this video because we're already over half an hour in. What I am going to go do is I'm start a new video. It's called, I'll basically walk you through the deployment of this. The problem what's going to end up happening is the moment I add switches to the fabric and I go through the discovery process, what will end up happening is they will be rebooted and brought on as a fabric enabled switch. So a controller managed switch. I still have access to do everything on them. Like, you don't lose CLI access, everything still is there. Matter of fact, you can use this to deploy everything in the beginning and then make a whole bunch of changes afterwards. Your fabric controller will be out of sync. So I'm going to do that in the next video, and then we will go through it'll take some time for the switches to reboot. But we're at a good spot now where we can actually do something. With that being said, I want to thank you guys for stopping by and hanging out with me, and I'll catch all of you in the next video.